So ladies and gentlemen, please put your hands together for Mr. Stefano Alberico.
Yeah. Okay, good afternoon everyone. I'm hungry as you as well, so I'll try to keep it in the right time. So today I'll bring you and talk a little bit about the privacy and security in digital communication, which means how people connect to each other, how they exchange data, how they talk, how they send files, and we have a solution for this. Now, we talk first about privacy. So privacy, not only about your identity. So nowadays, you use a lot of apps on your phones, and a lot of data actually extracted from that phone, and also the identity of yourself. Like, usually your phone number is used to identify within the system. But the problem is also related to many other different kinds of data that could be extracted from your phone, and actually many times you're not aware. I'm sure you install application on your phone and you never read the TNC, terms and conditions. And if you go and read, you pretty get ahead. I mean, many applications they extract all your browsing history, your phone numbers, and then those data can be correlated. So there's a lot of information actually that are leaking out of your identity, and you're connected to your mobile phone when communicating. And another factor is very important about security. Now, security, we could traditionally define it as the way of trying to make sure that the data you send across, you transfer to your colleague or your friend, actually are encrypted, so they are not intercepted and they are not tampered with. Because what can happen again is like data are stolen on the way, or if you use encryption, maybe your encryption keys could be taken away. So there is a lot of actually work going on to try to ensure that those communications are safe. Now, I have one question, like how many of you have heard this Meltdown and Spectre, which is not the bad boys from James Bond movie? So you heard it, not many. So this has been, I would say, a major event for whoever following encryption is aware of this stuff. This is really major bug which has been found, and they say this has been found a year ago, but they told us only a few days ago. So in between, you can imagine what they've done, maybe even before. Anyway, this is a bug which is affecting, I would say, almost every hardware architecture on the chip level. We're talking about Intel, AMD chip that runs in our phone, our laptop, our PC. So more or less, all of us are affected. And I'm making a long story short, basically it's all our data could have been in jeopardy, it could have been actually stolen. We don't know really yet the extent, and I'm sure there will be a lot of talking going on. And now I want to talk also about our solution, the way we tackle this problem. So we give you an app to install in your phone. At the moment it's Android app for security reasons. And through this app, basically give you some services. Mostly you can talk to people, send file, audio, and codes. And we have also a wallet, so you can make actually crypto payments. Now, one major difference, there are many solutions out there, is actually we care a lot about your privacy and actually your identity. So we don't use phone numbers to identify users in the system. So in the system, you are completely anonymous. We give you a serial number, which is stamping that QR code in a card, and you need to scan with the phone to log in. That's all the system knows. You are user 1, 2, 3, and the other guy is user 4, 5, 6, and you can actually then connect with each other. But then the beauty that we are bringing to the market is this device. So we don't trust operating system, we don't trust phones, can be hacked like you open or not. But we rely on the encryption can actually all run on an external hardware device. This is the physical device that you can plug and connect to your phone running our app. And of course, on that, this goes through, let's say, internet. And on the other end, you connect and you talk with your colleague and friends. So here we are talking about end-to-end encryption, so that two persons, and eventually more, can talk and exchange files or even actually crypto payments in a very secure way. And again, the encryption runs on a hardware device, not anymore on a software. Now to make a very specific example, this is the, let's say, extreme use case that we can offer. And I would say maybe for the paranoid that are afraid of being intercepted. Imagine you to send a file. If you are really paranoid, you work with a laptop which never touched the internet, so-called airtight or air-gapped laptop. So you work in this laptop, and when you need to exchange a file, because usually if you work with some people, you save the file in a USB memory stick. And then you take the stick physically, you ship it by post, or you give physically to your colleague. This is the safest way to work, more or less like writing paper and sending letters. So imagine you have this kind of files, it could contain a message or whatever you want, audio or anything. Now this file is in your USB. Now you connect directly this in our hardware device. This hardware device, it's actually controlled by the phone, which is only remote control that decide which file to send to my colleague. But all the magic happens in this little chip. Now, as I said before, we don't trust actually anyone, so we don't even trust any brand building encryption chip. That's why I mentioned the Spectre before. So we build our own FPGA chip, our own custom chip, which means there is no credit system in there, there is no branded, unknown architecture. It's a very pure and simple encryption algorithm built on top of a custom chip, which actually can be inspected, it can be verified very easily, doesn't contain any backdoor. So your important files are encrypted directly in the hardware and then sent across through the internet to your colleague and friend. And the files are decrypted directly in the hardware and saved directly to the USB. Now, for those who are a little bit more technical, here you need to imagine that encryption happens in the hardware and the private keys, that's the most important keys, are inside the hardware. The phone doesn't have any. And when you send the file, here we're just talking about, from the phone, we list the files and we pick and send. So we actually don't visualize any file because of course your phone could be hacked and someone could read the screen the moment you type something. So this is the extreme use case to send across any type of information and encrypt it end-to-end in the hardware. Now, so just to summarize. So then on top of this end-to-end, I mentioned a couple of times, since we built this very nice encryption chip, then it was kind of straightforward for us to implement also a crypto wallet. At the end, we have a cold storage, because we have a device, physical device you can put in your pockets, and this can handle also the cryptocurrency. Now we'll start with a simple ERC20 and different bitcoins and Ripple probably. But then, of course, it's going to be expanding. Now, this is for us just efficient, because I had some people, coming and say, "Oh, okay, it's another crypto wallet." I said, "Well, okay, that's just efficient." That's why I describe the way all this. Now, the blockchain, because of course, moving from a centralized architecture, typically this kind of end-to-end encryption, many of them works to a central server. Now, we are decentralizing to take full advantage of blockchain and the advantage of actually being distributed, because when you are centralized, also one problem is the single point of failure. Anyway, you go through a server, so that could be compromised. So the first step would be actually to distribute the ID, so we actually connect with the token your digital ID, so the serial number that we saw before can be actually distributed. But the real nice beauty will come with the next step. So we actually have if you can imagine, we have a distribution network, a communication network. We allow data to send across end-to-end encrypted. So we want to open up this network actually with the help of everyone. And we will provide APIs. Anyone can build or has his own application, can use the API and access our network. So we provide the media, the transmission, and end-to-end encryption to your single application. And then, since we bring our token, then we can, let's say, you as a user might pay, to use the network, and then the node that will be this network can be rewarded with the token. So we create an economy itself, and then we just, help to launch it, and then basically it can go on its own. So we don't need to be there anymore. And so for this, actually, we are launching an ICO, which is in about 20 days. So it was a nice discussion before, because you're doing an ICO. are about to launch it, and those are the dates, but anyway, in about 20 days. And the last bits, actually, I think I can announce, because this information is supposed to go public today in US time, maybe we're a little bit ahead. But we have a cooperation with the Reels.com. Reels company is an American company also dealing with hardware security. So now it's very technical, but it's better you go and read it yourself. I don't want to take too much time, but it's going to be a very, very strong combination between our transport, encryption transport, plus their attestation. So they are very strong in making sure that the user is the one you say to be, and it's connected to the device. So there will be then other partnership coming, but thank you very much for listening, and if you have any questions, I will be outside also to my booths, and I can show you what we have. Thank you.